I work as a solution architect for this fintech startup at ITPC. I've been working with them for close to 5 years. Uh, so I'm going to talk about digitally signing a document right now. You must be aware of the process of digitally signing a document. You must be doing it in your day-to-day activities. If you go to any bank, if you get any new financial product or a loan, basically you typically sign a loan agreement, right? So as part of that, you digitally sign the document. And there are a lot of vendors in this space, DocuSign being the primary one. Apart from that, there are others like Adobe Sign. Then there is Dropbox. Dropbox also bought a company which specializes in this digitally signing of the documents. And then there is HelloSign, Sign Now, and all that. So digitally signing of the document has been there for quite some time, but then why am I talking about this in this presentation? Okay, so the reason for that is we have built our own e-signing microservices based framework, which we have open sourced it. And we want to ensure that frameworks get utilized by fintech companies or startups for that matter, right? So digitally signing of documents, it's not necessarily for a fintech company. It can be for any other company who requires any signing of the documents. So that's the main reason why I'm talking about this in this presentation. So as part of this presentation, we are going to cover following agenda. Okay, so first I'll start with introduction about myself, what I do and all that. The second is a demo and the key takeaways. So demo is basically going to be for two channels, one for a mobile application as well as one for a web application. Then we will talk some about regulatory standards, e-sign act primarily. Then we'll talk about a case study as iGrid works. So I work for iGrid works for almost like 5 years. I've helped them build their entire backend infrastructure. So I talk about that case study and how we built the entire e-signing framework as part of that case study. Then we will delve into the technical details of the e-signing microservice, where I'll cover details about the technical stack, then the APIs associated with that e-signing microservice. And each of the APIs will go into details and show how we implemented the e-signing process. As well as finally, we will cover security measures. So how do we ensure that the document which is being generated is we maintain the authenticity as well as the integrity of the document, and the document doesn't get tampered. So how do we do that? So that section we'll be covering that. And finally, we'll be talking about the open source availability. In this slide, I'll be covering the open source project. So I'll walk you through all the assets and all that in the on the GitHub page, as well as we have a demo over there. Okay, so that's the in general agenda. So first we'll start with an introduction about myself. So I work for this fintech company called as iGridWorks, obviously the solution architect. I've helped them build their entire backend infrastructure. So for the loan application process. So this loan application process primarily comprises of like credit underwriting, then fraud detection, identity verification, biometric validation, then KYC, customer KYC, as well as signing of various documents, right? So this entire stack, I have helped them build. I've been working with them since 2019. I've been building this for close to like 5 years now. And so that's about what I do at iCreditWorks. My expertise is in building microservices and event-driven services. I use Kafka very heavily for building those event-driven services. I contribute to these online forums like DZone, InfoQ, Balden. I have my own personal blog as well, as I've done some research papers based on the findings based on the work that I've done at this fintech company. I act as a judge for these industry awards as well as hackathons. And my prior experience before iCreditWorks, I used to work for Morgan Stanley. I worked for Bank of America, Associated Press, doing all these consulting gigs. And prior to that, I was working with Microsoft Consulting Services for close to 7 years. So I built microservices in both Java as well as .NET, which is like a kind of a unique experience. So I had exposure to both. I had like in the .NET side, I had used heavily like .NET-based web APIs and all that. And on the Java side, I have heavily used Spring-based microservices. So that's about myself. Okay. So now I'll show you a quick demo. Okay. So let me. So this is the demo about our mobile application. Okay, so let me take pause over here a bit. Okay, so this is our like. Let me start from first problem. So as part of the customer journey, right, for getting a loan, right, the customer goes through various steps as part of the loan application process. And at the flag end, basically, I would not say flag end, but like couple of steps before the loan application process gets completed, he goes through this digital signing process, basically, where he signs an agreement with us. So in this case, he's signing a document called as master promissory note, which is an agreement between iCreditWorks and then the customer. So as you can see, it's a pretty long document. It contains all the terms and conditions associated with the loan and terms and conditions for different products for that loan as well. So over here, what you are seeing is basically an HTML content which is getting rendered. So the API is returning an HTML response through HTML document. And in the mobile application, we have a web view basically, which is hosting this HTML content. So what is a web view? Web view is basically a browser control or a browser instance which you can use to put it on a mobile application. So as you can basically, if you want to render any HTML content, you typically just use web view over there. So as you can see, the customer is just going through the whole document over there. And one thing which I wanted to highlight was master promissory note is something which customer signs only once. If he takes like n number of loans, he doesn't have to sign the document. Obviously, he has to sign some other document like a truth and lending document, which is like an FTC compliant document, right? So where we provide all the loan terms, interest rates, and all that. So as you can see, the user has completed the going through all the documents. At the end, you will see basically if you scroll right, you'll see this thing, the borrower signature over here, and at the end you'll see this let's sign. So if I play this over here, if you see over here, it will the let's sign thing will appear over here. So now the user clicks on let's sign. Basically, the user signs the document. That's when we capture the signature. And once the signature has been captured, we show the user the digitally signed document there. So, and the user can review the document over there. So on that document, right, the user could change the signature as well if he feels that the signature is not good. So if I go back to this video, if he doesn't like this signature, right, there's an icon over here. You can click again on that, and it will again pop up that signature thing. You can again capture the signature over there. Now, once the user clicks next, that's when the signing process gets completed and the applicant moves on to the next step. So that was our one channel, and this is another channel which we use for signing of the document. So in this case, it's not the customer who is signing the document, but it's more of the network provider. So we usually have tie-up with these different dental networks, and whenever these dental networks get onboarded with iCreditWorks, we need to ask them to digitally sign the document. So as part of that, they go through some onboarding process, and one of the steps is to digitally sign the document. So as you can see, the framework which we have built, it caters to both. It caters to mobile application as well as to the native mobile application, as well as to the web applications in general. So those are the two primary channels that we support. Now I'll go back to my presentation over here. So that were the two demos. Now I'll jump on to the actual meat of the presentation. First, we'll start with regulatory standards. This is again like a bit of a boring stuff, but I had to put it. So the whole e-signing is governed by this e-signing act. So what does this e-signing act say? Basically, it says that the validity or basically the weightage of someone signing a document digitally and someone signing the document physically on a hard copy is one and the same. So that's the major guideline. Apart from this, it gives you guidelines around the record retention, how long the document should be preserved, as well as who should have access to these documents, right? So if there are multiple parties involved, you need to ensure that all the parties get the signed document and all that. Along with it, it provides some compliance measures, the signed document has to be immutable. So what I mean by that is, if someone tampers with the document, right, you should basically indicate that the signature is invalid, which will ensure that the integrity and the authenticity of the document is maintained. The third thing is basically you have to uniquely link the signature to a signatory over here. So these are some of the compliance measures which the eSign Act provides. So in general, that is about the regulatory standards. So now I'll jump on to the actual case study for building an in-house e-signing microservice, right? So for us, building an e-signing microservice was not just a mere technical decision. It was more of a well-rounded, well-thought process, considering primarily three major factors. One was cost efficiency, second was reduced external dependencies, and third was enhanced UI customization. So let's delve into each of these. So cost efficiency. So as you can see, we are originating a loan on a mobile device. Now, when we originate a loan, we have to go through multiple external third-party services. Like first, we have to pull a credit bureau report. There's a cost associated with that. We have to do fraud detection. Then we have to do identity verification. We have to do customer KYC, and all these are like third-party external services. So if you want to reduce the cost for an application, then we have to reduce these third-party external dependencies. So that was one of the factors that we decided that we don't want to use this third-party vendor and instead build our own. So that was first reason. The second reason was reduced external dependencies, right? So if you are using any third-party vendor or a resource, you are kind of a hostage to that partner or vendor, right? So if their service goes down, then our application process stops as well. We'll not be able to get application process completed in that case, right? So we wanted to reduce that dependency, and our application, consider it's been like a fintech space, as well as like in mobile application, it has integration touch points with lot of different third-party services. So if we minimize one of them, it's like it gives us better opportunity to to maintain the application uptime close to like 99% over there. And the third big reason, this was like the very major big reason why we decided to build our own microservice, was enhanced UI customization. So for us, we were using this third-party vendor, which used to provide a UI. This UI was again web-based, and in the mobile application, it used to get rendered as an iframe within a web view, and we were not able to customize it as per our requirements, as per our UX team's requirements. We wanted to give like a unified experience for digitally signing of documents across channels, right? Like for mobile application as well as for the other applications on like the network onboarding and all that. So it was a bit of a broken user experiences on both of these different channels. So that's the reason we decided to build our own, first the whole backend framework. This way, once we have the backend framework and the services in place, then we should be able to build our own UI. UI can evolve. We can keep on changing that UI as well on need basis. So those were the major three reasons why we decided to build our own e-signing microservice. Okay, now I'll delve into on the next slide the actual journey of our on iCreditworks platform to build this solution, right? So before I do that, I just want to give you some background about iCreditworks, what it does, because I didn't cover that in detail. So iCreditworks is a fintech company. We primarily deal with dental financing. So the way it works is we have a tie-up with these different networks, like dental networks, and these dental networks have different offices. So if you go to that office, like as a patient for your dental treatment, then that office is going to send you a link. So you use that link, you download our app. Since we know that you have come from a specific office belonging to that network, right? When you're going through the loan application process, we will be offering you special products, special discounted products, because since we have a tie-up with that network. So that's how our business model works, and the way it works, the way we make money is obviously through interest, and as well as through the merchant discount fee associated with that network. So that's the background about iGrid works. So as part of our we have launched in 2020, and a year or two later, we wanted to launch a product called as Pay in 4, which was like buy now, pay later kind of a product. So you must have seen that a lot of companies offer that, like Affirm and a bunch of them which offer that, where you pay one installment upfront and remaining 3 installments within a span of like 6 weeks. So when we were launching this product, the loan ticket size for this product was very minimal. I would say it was from $100 to $1,000. Now, since the loan ticket size is very less, the profit margins are going to be very less as well, right? So we need to ensure that the application cost for that loan comes down. So that was major trigger point for us to start thinking about building our own microservice. So that's when that's the reason we decided to build our own microservice. So typically, the partner which we had, for which we were using this digital signing of documents capability, it used to cost us 70 cents per document. Now imagine if you had 100,000 loans, which we would eventually, we'll be spending close to $70,000 a year. So we wanted to bring down that cost. So that was like the major reason we decided to go and build our own microservice. So when we launched this Pay in 4 product, for that product only, we decided to use this framework. We did a pilot with that product. We evaluated close like first 50 loan applications. Once we were comfortable with those 50 loan applications, then we decided that we can go mainstream with this offering to other products as well. So that was basically how we started this e-signing framework and how we incorporated this framework. For us to build this solution, it took close to, I would say, 2 months with 2 developers to build this solution. And then we have processed so far a very large chunk of documents. I cannot quote the number over here, but it's still like quite a big number to process these documents. We didn't had any major hiccups. 1 or 2 hiccups we had where the user, like the fraudsters, basically they would not sign the document or just put a dot over there, right? So how do we mitigate that? So for mitigating that, we were putting earlier we didn't have a name below the signature. Now we started putting name below the signature. So that was one of the learnings which we had. But so far we have been using it across on the mobile application as well as on the other service lines of our business application as well. So that's the case study about iGrid works. Yeah, and then it's basically our other apart from cost saving, it was about taking control of our own UI and our own branding, right? That was again like a major factor for us to just go ahead and build our own. And when we decided to build this service, the one thing which we realized was the biggest challenge was how do we embed or take the user signature and embed it inside the document, right? Remaining all things are very easy, like you can easily generate a PDF, and then you always have database connect. You can always build APIs which interact with database and all that. But the biggest challenge was how do we generate these documents, right? And once the document is being generated, we need to ensure that the authenticity and the integrity of the document is maintained. So if you open up any PDF, right, you usually see at the top, the signature is valid if you have signed the documents. How do we ensure that we accomplish that? So that was like a biggest challenge for us to build this service. Okay, so now I'll delve into the actual tech stack, what it comprises of and all that. So there are like 4 major components for this microservice. Let's move this over here a bit so that I can. And so there are 4 major components. Obviously, first is Spring Boot with Java. Then how do we generate and secure PDFs, cloud storage, and database? So let's talk about Spring Boot with Java. So we have built a lot of microservices. We have built like close to 50 plus microservices as part of our fintech. Majority of these microservices are in Spring and Java, but some of them are in Python, like data science and data analytics space. Those microservices are in Python, and some are in Golang, but the majority of them are in Spring. So that was the major reason that we decided to go with Spring. Obviously, we have a large pool of developers with Spring Boot with Java, so that was an easy choice. Then the second big aspect was how do we generate and secure these PDFs, right? So for generating PDFs, we use the Chrome headless over there. So the way we use Chrome headless is through a Maven package. This Maven package is it's available on open source repository. It's like a wrapper on top of Chrome headless. So what it does is you give it an HTML to it, it will generate a PDF document for you. So for that, basically we use Chrome headless. And then how do we secure the PDF, right? So for securing the PDF, we protect that PDF or sign that PDF with a certificate issued by a certificate authority, in this case, Entrust. And that's how we protect the certificate. And obviously, the fourth thing is database. Every microservice or anything, we need to store the state associated with that document, right? So, like whenever the request comes in, we need to generate a unique identifier for that request or for that document. Then whatever the state is being sent, right? Whatever the metadata associated with that document or the payload associated with the document, we need to store in some kind of a database. So in this case, we chose MySQL. But all this as part of our open source project, which is available on GitHub, you will be able to easily swap the repository layer with any other repository layer, like my Postgres or NoSQL repository layer as well. So as part of this framework, we have primarily main two APIs. First is to generate a document, and second is to take that signed signature and embed inside that document and give back basically a signed document as well as a signed PDF. So these are the two major APIs. First one is BitLight. The second one is where all the magic happens, where the signature gets posted, the PDF gets generated, we protect that PDF and all that basically. So we'll be covering both these APIs in detail in subsequent slides. Okay, so this is the first API. So if you see over here, so we have this URL and then this request body. But before I delve into this request, this API and the request body, I want to talk something about templates. Okay, so what is a template basically? For us, the template is basically an HTML content or an HTML document. So this HTML document is like a combination of static text as well as dynamic text. So this template comprises of all this static text over here, whatever you see over here. And these are all the templated variables. I think if you have learned if you have used any of these not open source, but any of these front-end frameworks like Angular, you can easily correlate these templated variables. In HTML, you usually have these like a templated variables. So all our documents which are getting generated, right? All of them basically use this concept of templates over here. So let me show you some other examples as well. So if you see over here, this is again one of the TILA documents, like a Federal Truth and Lending document. This is like an FTC you need to provide for each document. So this again is like a template. So over here, you will see all the static content as well as some of these dynamic content which gets filled in. Similarly, along with the documents, we do send emails to the users. So these email templates are again based on the concept of the template. Basically, the template is again over here static text as well as dynamic text. So the concept of template is very important for us, and we have used that across multiple places for delivering comms. Now these comms could be like push notifications, SMS, emails, letters as well. So all the HTML content which we send to the customers are in form of this template. So the way it works for us is we take these templates are managed by content team. They publish it on GitHub, and then we use that basically we assign every template of code. And whenever someone wants to send a communication or generate a document, they will just send us that document code, and based on that, and along with the payload, and then we will generate a document. So now coming back to the e-sign piece, right? So when someone calls this, the consuming application, when they call this API, right? So they send basically the document code. So as I mentioned earlier, we have a lot of these document templates, right? So we for master promissory note, there's a specific document code over here, MPN, and then the context ID. Now the context ID can be anything, which is an identifier for which you are generating this document. In this case, we are generating for a loan application. That's why we have a loan account ID over here, something like a loan number 100 something. Then the third parameter is locale preference. How do you want, in which language you want to generate this document? Now, typically, for us, we support two languages, Spanish and English. So we need to maintain two flavors of these templates, basically one in English and one in Spanish. So depending on the locale, we need to pick up this appropriate template. Now, the last major factor or the major payload in this request body is the fields. So if you see over here, fields is basically a collection of key value pairs. So the current date, customer address, line, city, state, zip, right? So these variables and then the template variables, they have to match. So what happens is when we are generating a document, right? We parse this template, we take these templated variables and go to this fields collection, get the values associated with it, and replace in the template. So that's how the dynamic content gets populated in the documents, which I'll cover in the next slide. Okay, so this is our first API. So this is where all the so whenever the user lands onto the first page where he sees the document, right, which he has not signed yet. So that's the API over here, which is getting called. So as part of this API flow, the first thing that we do is we go and get the template associated with that template code. So in the previous request payload, I had shown you one template code over there, right? Like MPN-01. So based on that template code, we go to the database. For that template, we go and pick up the cloud storage path. Once we get the cloud storage path, we pick up the template from the cloud storage and then load it in memory. So now we have the template loaded in memory, which is a combination of static text and dynamic text through templated variables. And we have the fields collection, the dynamic variables. Now, what we do is we parse this template. So there is a specific algorithm and pattern matching regular expression that we use to get all the list of these templated variables. Then we start iterating through all these templated variables and then look up for each variable, the value associated with that. I mean, for each of this templated variable, we look in the fields collection if there's a key with that name. If there's a key with that name, take the value associated with it and replace it in the HTML content. So when we load the template, it's basically a string content. And for each of these template variables, we'll replace that with the dynamic value over there. So that's how we build the raw HTML content for that document. Once the raw document content has been done, then we push that HTML content to a Chrome headless through that Maven package and generate a PDF out of it. So that PDF basically, so now we have two documents, right? One is an HTML and one is a PDF. Now, what we do is we persist those HTML and the PDF document in cloud storage. Once we have the cloud storage paths for that, we take those paths and then persist in the database. So that's how the whole document generation gets completed in this microservice. And the HTML content is the before we send that to the response to the API, right? The one thing which we do is we generate a unique identifier for that request, like the e-sign document UID. Along with it, we persist all the metadata which has been sent as part of the request payload, which includes the template code, the fields collection, all the other details, and the cloud paths of the generated documents, which in this case was the HTML document and the PDF document. We take those take those attributes and then push it in the database, the one in MySQL, and when we return the response, right, the response is in form of HTML, because in the first API, if you had seen the content type, there was a content type parameter in the URL. Usually it is HTML, but if you want, you can request for PDF document as well. So when the response is getting returned, as part of the response header, we return this unique document UID as well, so that for all the subsequent calls, we can anchor on that document UID. Okay. So once the HTML response is sent to the UI, the consuming application just picks up that HTML content and renders it as is in the document. So that is the first API. So this is a comparatively simple API and simple. There are not many things happening. The subsequent API is the one basically where it's a bit more involved and a bit more complex. So I'll jump into that. Okay, so this is our second API. So in this, basically, first you saw that in our demo that the mobile application, the user saw a document which was an unsigned document, and then user clicks on basically let's sign. Then we show pop-up, and he basically signs the document, right, or captures his signature. So once the signature is captured, the client application gets the blob content of that image on the browser as well as on the mobile application, and posts that content through this API to this to generate a signed document. So if you see over here, in this, the URL is having this e-signed document UID. So this e-signed document UID is the unique identifier which has been returned by the first application, right? The first API. So that UID gets sent. Along with it, the request body. The request body is again a form data. In this case, it's only one image. But if a document requires that you need to sign the document as well as you need to capture the initials of the person who is signing it, then you can send multiple images over here as well. So that's the interface for the application. Now let's delve into the actual second API where a lot of things are happening. So first, once the API call comes in, the first thing that we do is get the document. So as part of the API URL, you have the e-signed document UID. Based on that document UID, we load up all the state associated with that document from the previous API, right? So in the previous API, we had persisted the template code, then all the data associated with that document and the path, the cloud storage path, all that we bring it in memory. So once that is there, then the second step is the step where we sign the basically we store the signature which has been sent as part of the API into our cloud storage, because we need to store the signature which is captured securely in the cloud. Now, and once the signature is been saved in the cloud, we have the cloud path. Now, for that cloud path for the signature image, we generate a pre-signed URL. So what is a pre-signed URL? Pre-signed URL is a limited time access to a cloud resource for a limited time. So let's say if you want access to a cloud resource for a few minutes or a few seconds or a few hours, you usually generate a pre-signed URL. And why do I need that? So in the HTML content, right, where we need to render the signature, basically we use the image tag, and as part of that image tag, we have a source attribute. Now that source attribute has to be an image which can be rendered. Now we can easily put an image path which is publicly available and it will automatically get rendered, but we can't do that with the signature of the user, because the image is getting stored securely in the cloud. Right? We cannot expose that cloud resource to public, right? So how do we get access to that resource when the HTML is getting rendered, as well as when the PDF is getting rendered. So when we send the HTML content to this Chrome headless browser, right, to generate a PDF, so it actually renders a document. It tries to resolve or get the whole HTML content and render the HTML content. As part of that rendering process, it will try to load the image as well. And once everything is loaded, then only it will basically export as PDF. So it is very important that when during that PDF process, the user's image signature gets loaded appropriately, as well as on the mobile side as well. When the raw HTML content is set, when the user is viewing, he should be able to see the image. So the way we achieve that is using this pre-signed URL. So if you see over here, this is an example of a pre-signed URL where it has basically the S3 path as well as some tokens associated with it. And this pre-signed URL is supported by multiple cloud providers. I've used it for Azure as well as currently we use it using AWS. So both of these platforms, but I'm not sure about cloud storage, but I'm pretty sure they must have an equivalent capability for that. So, from a sequence diagram perspective, we saved the signature. After saving the signature, we generate a pre-signed URL. Now, after that, what we do is from the previous state, we had the template code. We load that template again from the database. So we are not using the document which was generated previously from the first API call. We are going to regenerate this document again over here. And there was a rationale behind that as well to regenerate the document. So as part of regeneration process, we go and fetch the template. Once the template is fetched, we also have the data which was from the previous API. We club the data and the template together and then generate a document. Now this document basically is an HTML content. Now as part of that process, one thing which we do is we try to look up for certain specific templated variables like customer signature 1, 2, 3, or customer initials. And for those images, we use the pre-signed URL, not the, basically we need to give an appropriate image source over there. So I'll show you how the HTML also looks for the signature in the next slide. So once the document has been loaded, the whole HTML document has been loaded. It has all the dynamic content, static content, as well as the URL for the customer signature. Now we take that HTML content and push it to Chrome headless. The Chrome headless is the one basically which will generate a PDF for us. So once the PDF is generated, now we need to ensure that the PDF document is secure and signed. For that, we first log the PDF. For any manipulation, there are APIs around it. Once the PDF has been locked, then we sign the PDF. When I say sign, it is a cryptographic signing using a certificate issued by a certificate authority. In this case, it's it's Entrust. We have a tie-up with Entrust to give a certificate, and there was a cost associated with it. Initial cost of $5,000, but eventually for every other renewal, there is not much cost. So we take that certificate, sign the PDF content with that certificate, and this way the PDF gets protected. So if someone tries to tamper the PDF, right, or change any content of the PDF, then it will always show on the top that the signature is invalid. So now once the HTML content, the PDF is generated, it is protected and signed as well. Now we have HTML content, PDF content of a signed document. So we take those two documents, persist in the database, persist in the cloud storage first. Once the cloud storage, once we have persisted in cloud storage, we take the paths associated with that cloud storage and then push it in the database. So this is where against that document UID. So this way we have the entire stack trace of that signing process. First of all, we had a context ID, which was a loan account ID. Then for that loan account ID, we have all the paths, the cloud paths for HTML document, PDF document, then basically the signature, as well as all the payload. So everything is stored. There are a couple of other things which we store as part of this API is the IP address And if we have a location access from the mobile app, we do store the lat long associated with that as well in the database. So if there is any audit or if there's any compliance issue, we can always use that data for that reason. Okay, so once all these things are completed, we return back the HTML response to the user. Now that HTML response is basically all the static content, dynamic content along with the signature image, and the user will be able to see the signed document over there. So once the user clicks next, then basically the whole signing process gets completed. So this is in a nutshell how the second API works. So let me delve into the signature part of the PDF or the HTML, right? So this is where the core crux of this is where we had challenges. So if you see over here in the document which the user was signing, we had this section, okay, where this, if you see over here, this section maps to this HTML content. So if you see over here, there's customer full name, sign date, time, and at the bottom, basically this sign date, time, right? And then at the top, we have this image, right? Sign, the class is sign image and the source. So if you see over here, the source is like it points to a template variable as customer signature. This is where we replace this templated variable with the pre-signed URL. And once we do that on the browser end or on the mobile application end, this is what you will see. You will have the signature on the top with the first name, last name, and the sign date over here. So this is how it will get rendered. Now, one thing I wanted to highlight is, as part of the open source framework, we have used pre-signed URL, but for iCredit works or we use a different concept. We don't use pre-signed URL, but it's up to, I mean, you can use both pre-signed URL as the limited time token concept as well. So what is this limited time token concept? So for us, any document which is stored in the cloud is managed by a different microservice called as documents API. So we have built one API as part of that document API, which will give you access to a particular resource using an identifier, like a unique identifier, which we generate and maintain it, and the token. So we can tell that when we can tell that for this document resource with this GUID ID, generate a token for these many times to be used. So if you use that API, let's say 3 times or 4 times, and it has been configured to only render for like 4 times, and if the 5th request comes in, it will start giving you 401 error over there. So that's how we use this limited time token concept. Earlier, we had this similar concept for one-time use, but we have extended this to use for n number of times, right? So primarily we need it for 2 times, one to render the PDF or generate the PDF, and one for when the actual HTML gets rendered on the mobile application. So 2 times we need it, but as a backup, we have configured that token to be used for like 4 times. So in case the user refreshes on the mobile application, we don't have that capability, but in case for whatever reason the page has to reload, then we should be able to use that token a couple of additional times. So that's how we use. Now you can obviously use this solution as well as this. We have not open sourced this one, but we have open sourced the pre-signed URL. So that's how the signing thing works. So it's basically a trick of a bit of a HTML as well as some of the cloud the capabilities which are provided by cloud service providers. So that was about these 2 APIs. So now let me jump into the security measures in e-signing. So now, how do we ensure that the authenticity and then the integrity of the document is being maintained, right? So for that, we use basically we use a certificate. This certificate is issued by a certificate authority and trust. So when the PDF is getting generated, we sign that PDF document with this certificate. So as part of that, what happens is when during the signing process, basically we create a hash. That hash is then encrypted with a private key for that certificate, and that encrypted content is stored in the document. So when the user is basically loading that document in a PDF viewer, over there, what happens is uh, 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 based on the certificate's public key which is available, it will try to decrypt the hash over there. So once the hash is decrypted, it will create a hash for the content of the document. And if these two hashes match, then definitely the document is valid. If the hash doesn't match, then basically the document is invalid. So let me show you an example of that. Just a minute, I'm having an issue here. So if you see over here, this is a document which gets sent to customer. This is not a real customer. This is a lower environment document signed. So this is where the customer has signed the document, right? And basically the date time, and all this is all static data, as well as this is all the dynamic data over here. So on the top, if you see over here, it says that the signature is valid and all that, right? Now, what I've done, I've taken the same document and I have tampered the content of the document by, like, the last byte I have just modified. There was one number, I changed it from 4 to 5. Now, if I open that tampered document, you will see something like this. If you see over here, at least one signature is invalid, which means the document has been tampered. So if you see over there, that means the document is not valid. So that's how we protect the document. So as part of my presentation, so we had this, right? So like how do we ensure that the authenticity and the integrity of the document is maintained? That is done with us with the help of that certificate. Now, the second aspect is obviously storage security. So all these documents are stored securely in cloud storage. We encrypt these documents. So even if you get access to these documents, you'll not be able to see the content of the document unless you have the encryption keys. And the third thing is handshake protocol. So all these communications between mobile applications as well as the backend services, or with from backend services to AWS, it uses secure SSL. So the transport layer is protected over. So that's how we ensure the security and the we ensure that the document is well protected. Now let's talk about the open source availability. So this project is available on this GitHub site. So if I here, so this is our open source iCreateWorks e-signing, and this has all the content, the README file. So it has all the features. We have all these two demos over here, as well as one sample master promissory note, the setup steps required to install, and obviously some of these environments variables which we need to set. Now this document is protected by a JOT token. So you need to ensure that you incorporate all your application security in that microservice. So this is where we have open sourced it. I would really appreciate if you can star this document. That would really help me. So far we have like close to 92 stars, but I'm trying to gain more stars so that the project becomes more visible. So if you can help me star this project, that would be really helpful. So let me go back to the slides. So why are we open sourcing it? Is our main aim is to benefit any fintech startup or other startups. The thing that we learned is there are a lot of these open source packages which you can stitch and build a functionality, right? Like in this case, we built the signed microservice. So you don't have to be hostage to a particular vendor to build your digital signing framework or any of these services, right? So you can build on your own. So that was the reason. And if you look at it, we are saving like close to like $70,000. That's a ballpark number considering a certain number of loads. But And the initial investment was only 2 developers. We spent like two months on it. Once it is built, it's in production. We don't have any major enhancements over there, and we are saving like $70,000 over there per year. And so any fintech startup can just take this, put it in their cloud, and start using it, and then they can extend on top of it. We are just open source it. We don't have any license or anything.
How so giving example the loan is content hundreds of documents. Are you generating the documents? Who's generating the documents?
So when you hit that logical step where you need to sign the agreement, right?
Sure. So whenever we are signing documents, coming to the backend system.
Right.
The first time the user having the 100 pages of documents, 200 pages of documents, you are giving some kind of dynamic values. The dynamic values are providing by the user.
Right. No, they are not provided by user. So the way it works is you already have that data for that user, right? So the consuming application, so there are multiple services involved, right? So like whoever is calling our API, the e-signing API, it's again a different microservice. So it has a context of that user. So once the user hits that UI where it needs a document, right? At that point in time, we'll generate a document. So in this case, it was like 8 to 10 pages document. We don't have like 100-page document. So but yeah, like
if you buy the house kind of thing.
Yeah, it could. I mean, it could. Yeah, definitely. But if you really look at it, it would be more of most of the content is static content, right? Yeah. So you can just build an HTML raw like the template which we had. So and you should be able to load it. And
you told something you are calling external services like credit checks kind of.
Right.
I mean, once you receive the request from the user, internal are you calling to the external service?
Yes. So the way it works is we have I could show you as well. Let me go to this. So this is our web application. There's not much we can do apart from pre-qual. So this is where you enter all the information of the user, right? Like so first name, last name, city, states, SSN, and date of birth, and what's your next, right? You give a choice to choose a dentist for you. So when this call comes, this is when all those things happen. All the projects, all the KYC process.
So nothing but you are going to adding the user details to the system the first time.
Yes.
Internally, you are validating everything.
Yes. So once we get these details, we generate the user. We generate a loan associated with that user. So once that is done, we start doing all these kind of checks. And if we find that the applicant is fraudulent, we pend that case. And there are a lot of strategies around pending as well, like if there's a fraud alert on the credit report and all.
For example, I want to come to the system. I want to check one person related credit checks. So can I come and check the user related behavior?
Like, what do you mean by?
I mean, I want to know the one person related credit checks is taken or not. He's my customer.
Okay.
Can I come to register his details and check the details?
Yeah, you can. I mean, there are a lot of these services, right? Like even the fraud framework that we use is from TransUnion. They have an IDVision service.
Yes.
So we use that to validate the user using SPI. So if it returns certain score or a flag, right, we immediately turn down the application for certain users, and in certain cases, if it is coming from like a trusted channel like in network, then we basically find that case.
Oh, there is a TransUnion.
Yes.
XP TransUnion.
Yeah. And then we use something called as ECBSV as well, electronic verification of your SSN. It's a service provided by SSA office. So yeah. So there's a company called as Sentinel, which has a wrapper on top of this SSA office service. So that will be like a true validation, because sometimes users can create a synthetic ID in bureau reports and all that, right? But SSA office would have like a true identity data of that user. So in these cases, if you find there are like fraud alerts, or if the fraud score is a bit high, then we go to that service and just try to validate that user. And apart from that, as part of our loan application, we do biometric liveness check. So the user has to upload his driver's license and a selfie. So the driver's license and the selfie has to match.
So in the config file, you added some more certification related the certification resource, so you added among the e-sign interest issue.
Yeah, so that is the e-signed trust certificate. So basically, you need to so that certificate belongs to us, right? Which Entrust has given to us. Now you need to go and procure that certificate, generate a JPS file, and then put it over there.
The password is the custom password.
Yeah, custom password. That's a password to basically open the JPS file.
Either read that prefix you are calling this external service, are you calling this external service internally?
Which one is that?
In the e-sign project, there is a resource.
Okay. Okay, I'll have to check on that. We just conclude the presentation. Yeah, so that was my open source availability conclusion. In conclusion, I would say that the decision to basically build our own microservice was essentially to take control of things, primarily our own UI and build our own front end experience. So that was like the major driving factor. Our founder is basically very passionate about UI UX. So the first thing he looks is like UI UX. He has been pushing us to change a lot of things on this external vendor, but we were not able to change that because we had a dependency on their vendor's UI. So in a nutshell, I would say it has been a good experience for us to build a new service, and like we have open source as well, so that other teams or fintech members will start the same. And if you have anyone who can leverage this, that would be really helpful for me. I can in fact help with them to incorporate this kind of in the startup. So any questions? So no questions. I'll jump on to the next slide. So this is my detail. I have my LinkedIn link over there, my website. I do contribute to D-Zone and who are a member over there. Then I do contribute to validity. So if you are using Java or Spring, and if you have any questions, then you Google it, validity, and will always come upfront. It's a pretty good resource. I really like it. I contribute to that as well. And in fact, I recommend that you guys can also start contributing to that. So that's pretty much what I had. Thank you very much.